Okay, we want to solve quadratics to give the exact solution, which means no decimals to two decimal place type of idea. So we can do this by completing the square. It's one of the processes we can go through. So if we've got something like x squared plus 4x minus 7 equals 0, there's nothing that multiplies to 7 and adds to 4. So that means we have to do something else. So what we do is we take the b, this number here, and we halve it. We stick that in a bracket with an x plus 2, and we square it, and we figure out what that multiplies out to. We know it's going to be that because that's our whole purpose to doing it, but it's the last bit that's important, the plus 4. Right, so remember that this is x plus 2 times x plus 2. All right. Now what we've got to do is we've got to compare this with what we originally had. So we've got 4, but we want negative 7. So we're going to have to change this line here to being this, but we need negative 7 because that equals that. So we've got a minus 11 equals 0. Once we've got to this is where our perfect solutions, our exact answers actually come from. So we've got x plus 2 squared equals 11. X plus 2 equals the square root of 11, but we've got it squared over here, which means it could have been a positive and it could have been a negative. So we have to write plus and minus. And then we move the 2. So we've got our two solutions. They're negative 2 plus the square root of 11 and negative 2 minus the square root of 11 as our two solutions. Negative 2 plus the square root of 11 and negative 2 minus the square root of 11. And they're exact. That's a perfect answer. So that's the easy form. You may have seen that before. When we add a number in front, it becomes a little bit more difficult. All right, so we've got this 3 in front. We need to take that 3 out of the picture for a little while. So we're going to divide, we're going to move this over here first. So we're going to say, so over here we could have moved the 7 over here and then worked out that we had to add the 4 again. So this could have been 7 plus 4 equals 11. We're going to take that 3 out. X squared plus 4x minus 10 over 3 equals 0. All right? So, oh, no, we're going to move the 10 first. We're excited because that's actually easy. You can do it that way, but we want to make it easier. So we're going to take it like this instead. Equals 10. Now we're going to take the 3 out. Now we're going to complete the square on this little bit here. So when we complete the square on this, we're going to get x squared, x plus 2 squared. X plus 2 squared is equal to x squared plus 4x plus 4. All right? So when we put it here, we've multiplied it by 3. So we've actually introduced an extra 12. So if we introduce that extra 12 to this side over here, here it is in here, then we have to introduce it over here too. So we're actually going to have 10 plus 12. The 4 on the end times the 3 at the beginning. So we've got 3x plus 2 squared equals 22. Dividing by 3, remember it's a perfect answer we want, so 22 over 3 because 21 is 7, so therefore we'd have 7 and a third. We can write that, that's still perfect. We can't write 7.33 to 2 decimal places. Now we're going to take the square root, plus and minus 22 over 3, and we're going to subtract 2. So our two answers are there. All right? And we can do it with algebra too. We just have to follow that pattern.